If you are building AI agents and your code is full of if-else statements, retries, and loops, then LangChain alone will break, as it struggles with complex agentic workflows beyond linear chains. Let me show you why LangGraph exists. This is LangChain, an open source Python and JavaScript framework launched by Harrison Chase and the team, designed for building LLM powered applications through composable chains. It combines a prompt like prompt template, an LLM such as Chat OpenAI, with the GPT-4o mini model, costing about 0.15 per $1 million input tokens, and a chain like LLM chain, creating a linear flow that's easy to build, read, and extend with tools. This simple RAG Q&A bot, which improves accuracy by 20 to 50% over pure LLMs per benchmarks, uses Chat OpenAI, prompt template, and LLM chain, with a typical flow of retriever from vector DBs like Physis or Pinecone, then LLM, then answer, processing queries like what is RAG, which stands for retrieval augmented generation. LangChain, with over 85,000 GitHub stars and 10 million monthly PyPI downloads as of 2024, is perfect for RAG bots, summarization tasks, and one-shot or linear workflows, excelling in straightforward and predictable scenarios where processes don't require cycles or branches. Now imagine building real agents like those handling 1,000 or more queries per day in production, where the complexity quickly escalates far beyond simple linear chain that LangChain was designed for. Problems arise when you need to retry if an answer has low confidence below a 70% threshold, up to 3 to 5 attempts, ask follow-up questions for unclear user queries, or send risky outputs detected via moderation APIs like PII to a human for review. Maintaining state across multiple steps, such as conversation history up to 128,000 tokens in multi-turn interactions, also become a major challenge, leading to complex, unmanageable code structures filled with nested if-else logic that pollutes LLM prompts and scales poorly. This kind of decision logic doesn't belong inside chains. Instead, it's workflow orchestration logic that requires a more robust solution, like modeling the agent as an executable graph. LangGraph treats your AI agent like a state machine, providing a powerful abstraction for complex, multi-step, stateful processes in cyclical and multi-actor systems. Its core concepts include nodes, which are individual pure functions acting as steps; edges, which represent fixed or conditional decisions and transitions; and state, defined as a typedict for shared memory that flows through the entire graph. This state, for example, with fields like question as string, answer as string, and confidence as float, flows through the graph, allowing every node to read from it and update it, enabling truly dynamic and adaptive agent behavior without hacks. Let's look at how real nodes are implemented in LangGraph, starting with an LLM node like generate answer, which invokes the LLM on the state question and returns an updated answer in the state dictionary. Next, a confidence check node, such as check to confidence, evaluates if the generated answer meets a threshold like 0.7, deciding whether to route to retry for looping or done to complete the process. Finally, we build the graph using state graph for agent state, adding nodes like generate, bound to generate answer, defining conditional edges from generate via check the confidence to either retry, back to generate, or none for end, then setting the entry point and compiling, optionally with a check pointer like memory saver for persistence. This setup allows for natural looping and complex decision making without hacks, nested if-else statements, or polluted prompts. The graph itself inherently controls the flow, supporting streaming in under 100 milliseconds and scaling to 100 or more nodes. Think of a customer support agent as a perfect real-world example for LangGraph's capabilities, used by companies like Klarna to reduce resolution time by 80%. The agent's flow involves first understanding the query, then searching documents for 10 to 100 results, generating a response with an LLM, verifying policy compliance using tools like LaMeGuard, and potentially interrupting for human review if unsafe in 1 to 5% of cases before finally sending the response. This is not a simple chain. This is a graph with 5 to 10 steps designed for robust multi-step agentic workflows that achieve 25% higher success rates on benchmarks like hotpot QA compared to pure LangChain React agents. LangChain gives you the essential building blocks for RAG, tools, and prompts, while LangGraph gives you precise control over multi-step agents, loops, and retries, and human-in-the-loop interactions with persistent state. I have added the complete working code in the video description as a Google link. You can directly use it or modify it for your own projects. If this video helped you understand LangChain and LangGraph better, don't forget to like and subscribe to the channel. And if you have any doubts or want me to cover a specific use case, drop your questions in the comments. I personally read and reply. See you in the next video.